Vintage Story's gameplay and progression are inspired by the natural world and the actual history of human civilizations. To build the world, it uses a large range of natural materials and varied world generation based on real geologic provinces. Into these rocks, the game places geologic structures, carves caves to explore, and generates dozens of different types of real-life ores. The player is given a variety of gameplay mechanics to collect, mine, and process natural materials, to survive, and simulate an advancement through the ages. It tries to strike a balance between realism and playability, a fine line between tedium and reward. Part 1 covered rocks, sediment, and world gen, and in this part we'll look at how it covers ores, their properties, presentation, and compare them to real life. We will look at geologic features like caves, salt domes, kimberlite pipes, and geologic mechanics like panning and prospecting. And lastly, I'll give my opinions on the actual gameplay. I'm Nice, and this is part 2 of my geologic review of Vintage Story. Last time we talked about the rock cycle and how all rocks start out as magma. This is true for Earth as well. In the beginning, there was no core, mantle, or crust. It essentially started out homogeneous, at least at the large scale. Gravity pulled heavier elements down and eventually formed our core. It's mostly iron and nickel, but all the heavy elements are there too. 99% of Earth's gold is estimated to be in the core. This leaves the crust of the Earth enriched in lighter elements like aluminum. Geologic processes have been differentiating elements by density and chemistry on large and small scales for billions of years. On the large scale, you have the formation of geologic provinces. But on the smaller size, but still quite large in some instances, you have ores. Usually an ore is a concentration of a specific mineral or a group of minerals, and we are interested in one or more of the elements that they are composed of. But sometimes we just want the material itself. And no matter what ore we are talking about, we can reduce its formation down into 3 parts. You need a source, which can be primary or secondary, a means of transportation, often water, but there are others, and then a trap where it's all concentrated. In real life, this concentration of material needs to be high enough to make it economically useful. Many ore deposits in Vintage Story would not be considered ores in real life because the quantity is too small to bother with. Here is a sample of banded iron formation from the closed Republic Mine in Upper Peninsula, Michigan. The deposit was about 88% pure iron oxide. But for iron, that's not enough to be viable because many other deposits have higher concentrations. By comparison, this sample from Eagle Mine contains about 3% nickel and copper, and that is enough for it to be worth all the effort of mining and refining it. But in Vintage Story, if the player is mining it, we can assume that they think it's worth the effort, and therefore it's an ore. So with that in mind, as we go through the ores, I'll try and comment on the real-life versions, but mostly I'm interested in how realistic it is to find that specific mineral in higher concentrations in that specific rock. There will be inconsistencies with real life, and many of those are necessary to make a fun game. To display everything, I've mostly kept the same layout of the terrain-forming rocks from last time, with igneous, sedimentary, metamorphic, and soils. I've removed the sediment section since there are no ores that generate in them. And before we get into the ores that people commonly think of, we're going to start with a few materials that Vintage Story generates using the same system. Flint is one of the first resources you need in the game, and in real life, different people have different definitions of what is or isn't flint. Geologically, flint is cryptocrystalline quartz, the same as chert. It's easy to work into tools because the crystals are very small and you can get nice conchoidal fractures. It commonly forms as nodules in vugs in rocks, and a vug is a small cavity formed by dissolution, basically a little cave. Silica-rich waters enter the cavity, and if the pressure and temperature are right, they precipitate little crystals. This is also how some geodes can form. Since flint is a necessary step in Vintage Story, you can find pieces of it on the surface everywhere, no matter what rock you are on. But there are also deposits of flint that can be found in some of the sedimentary rocks, specifically sandstone, claystone, shale, limestone, and chalk. Quick side note, you can technically find flint in every stone due to how structures form. There is a specific ruin that has flint as part of its structure, and it uses the host rock as the base, so you can find oddities like flint in andesite. In areas where flint deposits can form, you can sometimes find clusters of flint on the surface. We will talk more about the surface bits later, but below them there is usually a deposit. And I'll be using a few techniques in this video to show the ore distribution. Sometimes I'll cut down through it, or I'll excavate around it, but I'll also be using the mod Block Overlay, which lets you highlight specific blocks you filter for, so we could use it to see all the flint in the area. Most of the ores generate as these disc shapes, and depending on the ore, they will be horizontal or follow the topography like flint does here. Flint actually has two generators, a regular one, and then an additional chance for a large deposit in chalk and limestone, which is the rock they are commonly found in real life. We can briefly look at the game files for flint. It has the two deposit types, and each has how common they are, what rocks it can generate in, and then the shape, size, and depth. For the rest of the ores, I'm just going to put these values on the screen so you can see specifics. What I'm calling weight here is how many times the game tries to spawn that ore in a chunk. You can just think of it as rarity. And the depth strat in the code is a percentage from the bottom, so instead I'm going to show it as a percentage from the top. So flint here only spawns near the surface. And if there are multiple types, I'll color code the values that are different. Another early and important resource for humanity and players is clay. It's an accumulation of clay minerals, and those are formed from the weathering process of minerals and rocks. In real life, you can accumulate clays in two major ways. The tiny particles can be washed away as sediment and concentrated where the wind or water current is low, like bends in rivers and the bottoms of oceans. This weathering also happens in soils. They possess a lot of minerals, and they still break down into clays. As water is soaking in and going through the soil, it picks up tiny clay particles, and they get carried down deeper into the soil horizon. Soils normally have a leaching horizon where it's getting stripped of clay, and an accumulation horizon. So it's a little example of our source, transport, and trap. Vintage Story has blue and red clay, which in real life could be the same clay. Clays that are near the surface can be oxidized, and iron will cause the red color. Deeper clays can be oxygen poor and retain their gray color. Depending on the exact chemical makeup, they can be blue, green, or even purplish. These are called glade soils, and I found some cool green ones when I worked in Madagascar a few years ago. Red and blue clays are generated near the surface in Vintage Story, as long as it's not dry and the average temperature is above -10. And there are two other cases for rare red clays in colder environments too. Clays normally generate in flat areas like they should, but there are some instances when they generate in steep terrain. In the files, there is a max Y roughness stat, which is only there for the ores that should be in flat areas, but it's set to 1, and I'm not actually sure what that value is doing. It could be that the check is at the origin point, and if the radius is large, it can go uphill, but I don't know. There are some lore reasons in the game why things are messed up, and we do have floating islands, so it's fine. The game also has fire clay, which is resistant to high temperatures and used for building ovens and refractory bricks. Fire clay in real life can be a variety of clay minerals, and really the name just means that most of the minerals that make it up have a higher combusting or melting temperature. You can make it in the game with calcinated flint. This is a real-life process. The calcium minerals are being burnt out and leaving higher temperature-resistant minerals that would be suitable to withstand the temperatures in ovens. Many of these being aluminum silicate clay minerals. In Vintage Story, you can also find natural fire clay in bauxite sands. Bauxite is a weathered rock, and that has many of its easier-to-dissolve elements removed, usually leaving behind aluminum and silicon, so that checks out. You can also find it under black coals, and in real life, there are commonly deposits of clay under coal measures, which we'll talk about now. The game has the same grades of coal as real life: peat, lignite, bituminous, and anthracite. And it has graphite as well. These are the preserved remains of plants that were in a low oxygen environment like a swamp and buried quickly before they were able to decompose. Sedimentary rocks are usually horizontal layers, and as you go down, each layer is older than the previous. In this way, they are a record of time. So the coal represents a swamp, and many coals have a layer of clays beneath them recording a drier time that shows some soil development called seat earth, and these clays are often suitable to be used as fire clay. This is not just limited to one type of coal, so technically all types of coal in the game should have a chance to spawn clays under them, except in the higher grades of coal, the clay would be lithified into claystone. The grades of coal in real life are based on their purity and percent of carbon. Peat is basically just dead plants. But if you bury it, the pressure and temperature increases, and with time, it changes into the other grades by converting the chemical structures of the plant material and deriving off volatile compounds like water. A vintage story does have each of these generate at deeper depths, but it's not representative of real life pressures and temperatures. And it is very cool that each grade gets thinner and thinner, so you can kind of see that as a compression of the carbon that's present. Obviously, you can find higher grades of coal closer to the surface in real life. It just had to be buried deeply at some point before it was exposed, either by plate tectonics pushing it up or erosion cutting down through the rock. Now let's move on to the more standard ores that people think of. Vintage story has several dozen ores, and many have multiple processes that could create them in real life. If I talked about everything in depth, it would basically be a semester-long economic geology class. And I know some of you would love that, but that doesn't really serve the purpose of the review. So instead, we're going to cover a lot of basics for ores while we look at copper, and then for the rest, I will talk about the more interesting parts and inconsistencies. Most ores are minerals, and those are made of elements and compounds. Usually they have two parts, a negatively charged anion and a positive cation. And often it's the cation that we are more interested in, like copper. Malachite is a copper carbonate, and we often group minerals by their anions. So when we say carbonates, we mean minerals that have a CO3 anion, like calcite, aragonite, dolomite, siderite, rhodochrosite. There are many other carbonates, and we'll talk more about malachite in a bit. Copper can bond to lots of things, and a common copper ore is chalcopyrite. It's a sulfide, and the ore that we mine is commonly formed from volcanic processes. When you have a large magma chamber, there are lots of elements involved, and many minerals like to form silicates, but there are many metals that prefer sulfides, and the two do not mix, much like oil and water. Not all magma chambers have a lot of sulfur, but when you do, you can have these heavier metal sulfides sink to the bottom of the chamber, and when they cool, you get layers of different species. Here is another example from the Eagle Mine in the Upper Peninsula, and this is called a massive sulfide deposit. This is just what the rock looks like when it gets out of the ground. These are called primary deposits, meaning that they formed directly from a melt, and usually quite deep. Once they are in place, you can start the process of secondary deposits. Even when the magma bodies are solid, they will still be hot for a long time, millions of years in some cases. Groundwater that is heated can dissolve elements, and convection can move that water to become the transport. If its temperature or pH changes, then it might not be able to hold onto those dissolved elements, and they will form secondary minerals. These minerals are precipitating in existing cracks in rocks and form veins, and sometimes they interact with the host rock and form carbonates, or silicates, or a variety of other mineral groups. Sometimes existing minerals near the surface can change just from oxidation. Some elements like copper, gold, and silver can be found just as their native metal too. We can divide how vintage story handles ores into a few sections. Like I mentioned earlier, for some ores you can find surface bits, and if you find these, they represent pieces of an ore body below it. The wiki uses the terms shallow and deep ore deposits to distinguish between ores that can and cannot have surface bits. And I don't really like this because it doesn't mean anything for how deep the ore can form. Ilmenite is a deep ore in the game, but you can find it near the surface. Here is a deposit from my survival world that is right in the mouth of a cave. Most ores have different grades, so when you find a specific deposit, the ore in it will be marked poor, medium, rich, or bountiful. There are ores that have depth bonuses, meaning that they have higher grades of ore the deeper you go, but some of the ores that can form surface bits also have depth bonuses. So to prevent confusion, I am not using those terms. I'll just have it on the screen if it can form surface bits and if it has a depth bonus. For copper, vintage story has two ores, native and malachite. The native variety can be found in every rock except for limestone and marbles where it's replaced by malachite. In real life, copper-rich water can interact with carbonate rocks, and this lowers the pH of the water, causing the copper to come out of solution and form carbonate minerals. It's commonly found with azurite, another form of copper carbonate. The native copper could have been deposited in any of the rocks as a vein, or for the sedimentary rocks, it could have also been a native copper vein that weathered out, became bits of sediment, and then was reburied to become part of the rock. Basalt has the highest possible grade of native copper, and in real life, metal deposits are normally associated with mafic rocks. Native copper in veins can be quite fine and detailed. The texture of these blocks look like nuggets to me, like they are bits of native copper that were rounded and redeposited, not veins, even in the igneous rocks. Which I guess we can talk about textures for a bit. The textures for these ores are overlays, or more accurately, the rock texture is an underlay. Each ore has 3 varieties to help with tiling, but the same textures are used for every rock and for every grade of ore. It would be nice if there was some differentiation between the grades, but that would exponentially increase the number of textures that needed to be created. Currently, every ore in a deposit is the same grade, but if that was randomized, you could use different textures for different grades and still break up the tiling that way without increasing the number of texture files needed. This would be really cool to have a visually distinct way to tell the difference between ore grades. One more thing in general, not all ores of the same cation are equal. For copper, if you had 100 grams of native copper, you have 100 grams of copper, assuming there are no impurities. If you have 100 grams of malachite, you have a lot of carbonate there too. So once you smelt it, you would only have about 57 grams of copper. In Vintage Story, 1 nugget of malachite and 1 nugget of native copper yields the same amount of copper when smelted. Same for the other ores like iron. And now, finally, we are equipped to go through most of the ores. While I'm talking about each one, I'm going to show which rocks it can generate in and what grades of ore are possible. By the way, no rocks only have higher grades of ore in them. There are only ones that can have higher grades in addition to lower grades. And then also on the screen, I'll place the name, the cation, the chemical formula, and all the game information. Cassiterite is a tin oxide and a common mineral in igneous rocks. And when I say common, I don't mean abundant. It's commonly there, just in small quantities. Tin in igneous rocks is normally in the parts per million range, but this is the source. It is transported and concentrated in hydrothermal veins, where we mine that, or more commonly, the veins weather out and we excavate that as placer deposits. This is some rounded cassiterite from a creek in the Yukon. It's rather heavy, 7 times the weight of water, so panning works well. And in-game, it's bountiful in granite, probably because it can be found in granite pegmatites. Considering that most of Earth's economic deposits are placer deposits, it should be on the surface more, but this is probably a game design choice. Bismuthinite is a sulfide mineral that I have never seen in real life. I actually hadn't even heard of it until playing Vintage Story. Bismuth isn't really found in sufficient quantities to mine as the primary mineral, but instead it's usually a byproduct of lead mining. The common crystals of bismuth that you see like this are all man-made. It does occur as a native element, but it's incredibly rare and not in this size. In-game though, it's only found in igneous and metamorphic rocks, and that doesn't have much in common with real life. Again, these would be the source, and then it would be concentrated in hydrothermal veins alongside other sulfides. Sphalerite is an iron-zinc sulfide. You can find it in primary igneous massive sulfide deposits and secondary hydrothermal veins, so it's associated with igneous bodies as well as carbonate bodies. The amount of zinc present in sphalerite is usually around 60%, but can range from 0 to 100%. And in-game, we just ignore the iron component. Carbonate rocks like limestone, chalk, and marbles should have higher grades in-game, and I'm not sure why slate and phyllite has the highest grade currently. Zinc is a very important element for game progression, so it might be because of that. In-game, we can also see another issue using the same texture for every ore over every rock. It's incredibly hard to make sure they stand out against every rock color. Zinc on granite is particularly bad. Galena is a lead sulfide, and in real life, it's commonly associated with sphalerite. It's one of the most common sulfide minerals in real life, and it has an incredibly low melting point. I'm not sure why it has higher grades in chert and shale in-game. Many of these decisions might just be for gameplay balance and diversity. In real life, sometimes a small amount of silver can be found in galena, usually under 0.5%, but even at that small amount, silver then becomes the more profitable part of the process, and lead becomes the byproduct. In-game, you can find galena in every sedimentary rock, and any deposit has a chance of generating silver in it. Usually these silver deposits are in high temperature hydrothermal veins of galena, and not the more common low temperature veins in carbonates. Quartz is an incredibly common mineral, but quartz ore, our primary source of silica to make glass and computer chips among many other things, comes from either large veins of crystals or pure sandstones. The sandstone that I showed last time is one of the purest in the world, 99.9% pure, and it's been mined for decades. In the game, we have quartz veins that can be in every type of rock, except the marbles for some reason. And when you mine it, you usually get a chunk of quartz, but sometimes you get a clear quartz. The distinction in real life is maybe the difference between a quartz crystal like this and then something like this. As a crystal is growing, it sometimes encloses pockets of the fluid it was growing from. Lots of crystals have these, but if you have millions, they all scatter the light and make the crystal opaque. The ore-forming fluid was very hot and had elements dissolved in it. When the trapped fluid cools down, those elements can form minerals inside the inclusion. The fluid can also shrink enough to create a vapor bubble. These fluid inclusions are real useful tools for geologists. We can analyze those inclusions and learn what the conditions were when that crystal grew. Opaque quartz is commonly called milky quartz, and you can find large crystals of this and other types of quartz in geode-like structures that can spawn in quartz veins. These are called vugs in the code, but are quite large. Vugs in real life are maybe fist-sized or so. Besides milky quartz, you can find rose, smoky, and amethyst varieties. Amethyst is just purple quartz and it gets its color from iron impurities and gamma radiation. Smoky quartz gets its color from aluminum impurities and gamma radiation. And then there are a few varieties of rose quartz that get their colors from different things, and it's not actually fully understood why. The vugs in the game have different rarities, with milky being the most common, then each following one is half as likely as the previous. Amethyst does have more places to spawn though. There is another underground structure called lakes in the code, and they seem to always have a vug attached to them, and it's usually amethyst or olivine, which we'll get to in a second. Also, not that I need to say it, but quartz crystals are not rectangular prisms. This is just a style and saving on polygons thing. Silica isn't that soluble in water, so you need some high temperatures to move it in any abundance. So these veins would all be from higher temperature hydrothermal fluids. This higher temperature water could also move harder to dissolve elements like silver and gold, which you can find as secondary deposits within quartz veins. And even though you can find the same grades of ore, silver is more than 3 times as likely to generate than gold is. Olivine is a magnesium iron silicate common to mafic and ultramafic rocks. Pyrrhotite is primarily composed of olivine and pyrazine, but you can't get that from the bulk rock in the game. Just like quartz, you need to find veins or vugs, except they are only found in pyrrhotite. And you can find vugs of it in the same underground lakes as amethyst, and those can be found in any rock though. Olivine is a high pressure and temperature mineral, so it really would not be growing in vugs, and it doesn't really have the same crystal habit as quartz either. The game does treat it just like green quartz, which it is not. There's also a chance for pyrrhotite to generate in olivine blocks, which is the same mineral, just the gem quality version. For iron, there are 3 ores in the game, and they are the primary minerals that we mine as ore in real life: magnetite, hematite, and limonite. And we mine them from banded iron formations. They can be nearly 100% pure iron minerals, thousands of meters thick, and they are billions of years old. The early oceans were warm, acidic, and had no free oxygen, so the oceans had a lot of dissolved iron in them. When photosynthesis kicked in, oxygen was released into the ocean and bound to the iron, causing it to drop out of solution. For billions of years, this happened and the rust piled up on the seafloor, and now we mine it. You don't find iron ore in rock. It is the rock. We don't have banded iron formations in vintage story. We have hydrothermal veins. In Australia, I found some veins of hematite, and even some placer deposits in a stream. So there's nothing really wrong with having these ores in rock like they are in vintage story. But it does look like the ores have just been randomly divided into different rocks to give some variety. There are a few inconsistencies between the blocks available in creative and in the game code. Iron ore sandstone blocks and slate blocks up to bountiful exist, but there is no sandstone in the iron file, and only up to medium for slate. This might actually be something that was just overlooked. If I could change anything about the iron ore, it would probably be limonite. It's basically what happens to the other ores when they get exposed on the surface. And in low oxygen environments, it can also form as bog iron. So I would place limonite only near the surface for the first few meters or something, and then maybe some under peat, as if it was bog iron. It would have to be in sediment, not rock though. Pentlandite is an iron-nickel sulfide, usually with a ratio of 1:1 for nickel to iron, and it's incredibly rare to find just by itself. Instead, it's usually found in massive sulfide deposits, in with other minerals like pyrrhotite, which is what this sample is. You can also have lateritic weathering of those rocks similar to bauxite, and that will further enrich the ores. In Vintage Story, you can find it in any igneous rock, which, I mean, you could have that if they were hydrothermal veins, but that could be almost any rock. In reality, it should just be in the pearlitite, which at least is where you can find the highest grades. If they ever add some things to the seafloor, real-life vents can produce a decent amount of nickel minerals. Titanium is the 9th most abundant element in Earth's crust, and titanium dioxide is the most common white pigment, which is used in everything. It's food safe, and if you've ever used non-dairy creamer, it's probably titanium dioxide making it white. Ilmenite is a common titanium mineral in igneous rocks, including kimberlite, which is where the highest grade in the game can be found. I'm not familiar with ilmenite in metamorphic rocks. Wikipedia says it's found in metamorphic and igneous rocks, but if you follow the source, it specifically says high-grade metamorphic rocks, which Vintage Story does not have. But even then, it's probably referring to rocks that were originally some igneous rock with high titanium. Most commercial deposits of ilmenite are found as placer deposits, and in Vintage Story, nothing is generated in sedimentary rocks. Chromite is normally found in, say it with me, mafic and ultramafic igneous rocks. It's key to the creation of stainless steel, and I don't have much else to say about it here. I don't have a sample, and its only use in Vintage Story currently is making sturdy leather, which is based in reality. Chromium is used in tanning, and it's a more modern method compared to using tannins. Uranium is the last metal we will talk about, and it isn't generated in the game yet. It has models and grades for every rock, but maybe that's just a placeholder. Uranium is actually more common than silver and gold in Earth's crust, so there's a decent amount of it. The most common form is uraninite, or just uranium oxide, a black mineral. In Vintage Story, the ore has a greenish yellow color, and there are many uranium minerals, several of which are green. Most deposits in real life are found in sedimentary rocks, so if it gets added, I would shift the higher grades to those. The next set of ores are non-metals, which only the first few have a real use in the game right now. Get ready to hear the word evaporite a lot. Borax, or sodium borate, is, well, a borate mineral. It's a source of boron, and borax itself has a lot of applications, including things like fiberglass production, cleaning products, and as a flux for metalworking. When a large lake or sea dries up, it leaves behind evaporite minerals, commonly salts, but there are many elements dissolved in marine waters, and evaporation is a great way to concentrate those elements into ores. Because of this, Vintage Story has them only occur in sedimentary rocks. Usually, evaporites are their own rock layers, and it's a mix of a few evaporite minerals, which can be quite thick. We'll talk more about that when we get to halite, but I think the texture should be more layered, more like our next mineral. Alum is also an evaporite mineral. There are a few exact types, but in general, it's a hydrated double sulfate salt of aluminum with some additional cation like potassium, sodium, or some other options. This is a mineral that I don't have any natural samples for, but I did grow my own crystals a few years ago. It has a ton of real-life applications, but Vintage Story uses it as a mordant, a material that facilitates dyes setting into fabrics. In-game, you can only find it in hot, dry environments, and historically, it's been mined from the Egyptian desert. On Earth, sulfur is one of the more common elements you can find in its native form. It is something that gets left behind in evaporite deposits, but it is also mined directly from volcanic vents. So I would add higher abundances to the extended crust and/or the large igneous provinces. While we're at it, let's deal with two more evaporite minerals that don't have any uses in the game yet. Kernite is a sodium borate hydroxide mineral that we actually use to make borax in real life. And fluorite, a calcium fluoride, and our main source of making hydrogen fluoride and hydrofluoric acid. The creative inventory has fluorite in metamorphic rocks as well, but that is not in the game code. The mineral comes in a lot of different colors due to impurities, and it's known for its fluorescence, which is where we get that word from, not the other way around. It's present in a lot of rocks, igneous, metamorphic, sedimentary, but I'm mostly familiar with it in carbonates, like this sample from southern Illinois. Phosphorite is not an evaporite, and it's not really a mineral either. It's a rock with a high amount of phosphorus. Usually, the phosphorus is originating from some organic material, and commonly it's in the form of fluoroapatite or hydroxyapatite, and we commonly mine it to make fertilizers. The game files don't include cinnabar with the other metals, but it's mercury sulfide and our source of that metal. Similar to the other metal sulfides, it's a hydrothermal vein-filling mineral, and I'm not sure why Vintage Story places it in metamorphic rocks. Historically, it's been used as a pigment and makeup, and in-game, it's the only red dye. Lapis lazuli is an historic blue pigment, and it's actually a metamorphic rock. Lazurite is the blue mineral, and it is a feldspathoid, similar to feldspars but less silica. Normal metamorphic rocks form along a pressure and temperature line that is standard in most places in the world. You go down 1 kilometer, temperature rises 25 degrees. You can get off this line in a few places though. If you have a magma body, you can have a high temperature and low pressure. This can create some uncommon minerals, and this is called contact metamorphism. And lapis lazuli forms from limestones that undergo it. Those limestones are usually also converted to marbles as well. One change that I would make is that I would increase the weight in extended crust provinces. Also, there is a model for it in bauxite, but it does not generate. Rhodochrosite is a manganese carbonate, and while it generates in the game, it doesn't have a use yet. In real life, it forms in hydrothermal veins, so any rock could technically host it. Corundum has no use and does not generate in-game. In real life, it's the same mineral as ruby and sapphire. It's a common mineral in metamorphic rocks, and it's quite hard, so we use it as abrasive media. Emerald is in the game, and it is the gem quality version of the mineral beryl. It's a common mineral formed in the last phases of magma bodies cooling down called pegmatites, and it's our main source of the element beryllium. Wikipedia says it's also found in mica schist and Columbian limestone, which is odd, and I'm not actually sure what that's based on, but it's probably why it's found in limestone and low-grade metamorphic rocks in Vintage Story. In real life, the vast majority is found in pegmatites, but we don't have those in-game. It is one of the rarest ores to find, and one of the hardest to accumulate the product. It only generates very deep in the world, and the deposit will only have 1 block of ore. Which is interesting because emeralds in real life are one of the rarest gems. And that is almost all of the ores, except for the ones that generate in geologic features. Like any good voxel game, there are a lot of caves to explore. In real life, there are a few different types of caves: glacial, lava, erosional, collapse, fractures, but by far the most common, and the image that comes to most people's minds, are solution caves. These are caves made of primarily carbonate rocks that have cavities dissolved in them by slightly acidic groundwater. Usually this dissolution happens at the water table, and this causes most of the caves to be horizontal. If the water level changes, then you can get different layers of caves, and in areas above the water, you can get the growth of cave formations. Vintage Story's caves are in every type of rock, and many have vertical sections in them. Most rocks are not able to be dissolved by weak acids, but I don't really have an issue with caves in rocks where they shouldn't be, because caves are fun, and it adds a lot to a game. And there are lore reasons why you can find caves everywhere, and ruins in many of them too. The bigger geologic issue that comes along with caves that go through any rock is speleothems of any rock also. Speleothems are the general term for all cave formations like stalactites, stalagmites, flowstones, whatever. Speleothems are almost always some form of carbonate, made from the elements the water dissolved on its way down into the cave. If you have hard water stains at your house, this is exactly what's happening. Even if you have a cave that is not in carbonate, you can have carbonate cave formations. Secondary lime deposits on igneous rocks are incredibly common because the calcium is so easily leached out of the rock. More realistically, all speleothems in Vintage Story caves should be limestone. In real life, the minerals are calcite or aragonite. I initially thought that this was a design choice, as it would be cool to get speleothems as blocks to build with, but they just break into stones when mined. The same with boulders, and I really want to build with these. In Vintage Story, you can chisel blocks to make your own though if you wanted to. On a side note, finding limestone is a common progression complaint that I have heard from players. It's used for leather making and a few other things in game, so making speleothems limestone would really help alleviate that. If you wanted to keep speleothems different rocks, another idea is just adding a layer of calcium to some exposed surfaces in caves similar to saltpeter, which is up next. For centuries, caves have been a source of saltpeter. It's potassium nitrate, and we have used it as a fertilizer and as an oxidizer in black powder. In-game, deposits of saltpeter can be found as thin films in all caves, and it's also usable as a fertilizer and an ingredient in black powder. Thing is, though, that saltpeter doesn't grow in caves by itself. It's usually processed from bat guano, and Vintage Story does not have bats. It does have locusts and other nightmares, so maybe it's their guano? You can find a few other natural features underground. Besides the lakes we talked about earlier, there are also some cavities with glowworms in them, and these have quartz bugs as well. There are a lot of things called glowworms in real life, but these seem to be modeled after a fungus gnat larva. I got lucky while I was in Tasmania and got to see some glowworms in an old silver mine. These spaces are usually not connected to other caves, and the worms are predators that eat other insects, so they would starve in these spaces unless this is a little enclosed biosphere. Lastly, for the actual caves, once you get below Y12, all caves are filled with basalt for some reason. I'm not sure why, other than it's deep and that's where magma is, which you can also find pockets of down deep. All geologic provinces can have magma pockets deeper in the world, and the liquid is called lava, which I guess is true if you have exposed it by mining. In the extended crust provinces, you can find these bodies of magma closer to the surface. You can also find thermal pools, which will always have magma bodies below them. This is similar to real life, where these sorts of pools and the areas around them are warmed by a magma chamber below them. In real life, the thermal pools get their color from extremophile bacteria that can only survive in a narrow band of temperature. And the gradient of color is the change of communities. Vintage Story recently announced travertine as a rock in 1.22 pre-release, and this is where you would normally find deposits of it. It's basically reverse cave formation. Hot groundwater dissolves minerals, then rises up and cools at the surface, and deposits layered carbonate minerals when it evaporates. Vintage Story doesn't seem to change the temperature here. The blocks themselves are labeled with temperature, and you will take damage if you get in the water. But if you get the climate data, it doesn't seem to really change anything. I thought it would be really cool to have this province be warmer, or have the average temperature increase as you got closer to a pool. You would end up with these little warm areas, even in higher latitudes. The same goes for temperature as you go down into the ground too. I didn't talk about cave temperature, but in real life, the effect of weather and climate really only reaches about 15 meters below the surface. And then as you go down, you start to increase in temperature about 25 degrees C every 1,000 meters. Vintage Story does that in about 160 meters. And even if you are deep underground, it still gets cold in the winter. There are also dry lake beds, which you can find in warmer environments. Or you could if this wasn't bugged. It turns out they've been unable to generate, and this will be fixed in 1.22. These dried lakes have layers of salt just below the surface, and same as we talked about in the other ores, these evaporitic basins are shallow and the rain is dissolving minerals from the surrounding rocks, and it gets concentrated here as it evaporates. These evaporite minerals are easy to dissolve elements, and the resulting products are a lot of salts, like sodium chloride, sylvite, but other minerals like gypsum and hydrite, and many more in addition to the ones we already talked about. Vintage Story has halite, and then sylvite as a child deposit that can occur in it. Sylvite is potassium chloride, commonly called potash, and often used as a fertilizer. To me, the most surprising geologic feature to learn that was in the game is diapirs. They call them salt domes, but they are something that I'm very familiar with from my real-life research. In the game, you can find them starting in sedimentary rocks and going down in a column all the way to the mantle. These are made of halite with some potash too, and in real life they can be composed of a variety of salts and evaporites because they started out as dry lake beds or seas. When you have a lake or sea dry out, it's still a low point and sediment can bury it. Compared to other rocks, salt is soft. If you put a lot of pressure on top of it, it can squish and move, like putting your outstretched hand into mud. It will squeeze up between your fingers. These structures are called diapirs and come in a lot of different shapes. As more and more sediment is put down, they keep climbing, or sometimes they die out. In Iran, there are some that are squishing out onto the surface, and they're called salt glaciers. The point is that they are squishing up as sediment is being laid down. In Vintage Story, if they are trying to represent diapirs, they should be starting in some sedimentary layer and growing up, not down. If you're curious about diapirs, I've done a video on them before. There are a few other geologic-based features underground, and one of them is kimberlites. In real life, these are the main source of diamonds. They are an ultramafic volcano that brings diamonds up to the surface fast enough that they are not dissolved by the magma on the journey. And while most of them are young geologically, they are old enough to not have any cones at the surface. It's all been eroded away. Kimberlite is the only rock in the game that only has one texture, so there's no variation and you get this really bad tiling effect. In game, the overlying rocks are draped over the kimberlite, but in reality it should use the generator that the salt domes use to have the overlying rocks be flat and the kimberlite go down to the mantle. In real life, they are primarily found in shield provinces, but in Vintage Story, you can find them anywhere. And they do have a chance to have diamond ore in them. But since kimberlites are rare themselves, it's a very low chance. But they're not the only place. The last ore that we will cover spawns in a common feature which can be hard to spot, but once you do, you'll be finding them everywhere. These are craters, and just under the surface is a rock called suevite. The name doesn't define the chemistry, but more its texture and what it's been through. The rock has been changed by a high amount of energy during the impact of a meteorite. The pressure of the impact can be great enough that it can form very tiny diamonds. In-game, it has a low chance for these craters to have diamond ore, but the main reason you want to find these craters is because they have meteoric iron. We can filter suevite and see the abundance of meteors in the game, which is ridiculous compared to real life. In all of Illinois, there has only ever been 12 meteorites of decent size ever found. I love that these are in the game though. They are plentiful enough to be useful and rare enough to be very exciting when you find them. If you want to get your meteoric iron eyes in game, head to a dry flat area and look for depressions that are out of place with the rest of the topography. Sometimes you can find suevite or meteoric iron stones on the surface too. The last feature I want to talk about are ruins. They generate on and below the surface, and a nice touch is that they are always generated with the local stone. One of the major expenses of construction projects is just transporting materials, so finding the closest source of a suitable material is something that an engineering geologist might deal with. In the hotter areas of Vintage Story, you can find termite mounds, and even they use the bedrock of the area. This is really cool because I've actually used anthills while making geologic maps in real life. In vegetated areas that don't have a lot of surface exposure, sometimes you can find ant mounds that have pieces of the underlying rock, and you can use that to know what formation you're in. We have covered all of the ores and structures, which means we can actually talk about finding them and just interacting with the world through the use of geologic mechanics. The classic image of a prospector is some old guy with a pick and a pan. The process of panning is basically just separating materials by density. You have sediment in the pan, you agitate it, and the lighter sediment gets washed out and the heavier parts remain. This is why it's used for placer deposits of gold. The nuggets are very heavy, and even small pieces will be left behind. In game, you can pan from any loose sediment, and this is a good source of early copper and some rarer items. In real life, the gold or other dense materials you're panning is coming from some source upstream. But in game, it doesn't matter where you are or what's around you. There is also bony soil, which has a different loot table and contains more archaeology-based items. This is where I got my early candles to make lanterns in my world. The ores you can get through panning are limited, and to progress, you will need much larger quantities. Prospecting in Vintage Story is handled through the prospecting pick, which is named after a real thing. Prospecting picks in real life are essentially just lighter picks, so you aren't carrying a heavy tool while you're trying to cover ground. Sometimes they have magnets on them, but there are so few minerals that are attracted to a magnet, it's not really that useful in my opinion. Just have one in your pocket. Old prospecting would involve just walking around and hitting things and trying to recognize minerals, or maybe follow some geologic contact. If you think you found something, you would dig an exploration hole, or maybe dig along a vein that looked promising. This would be horrible for a game. It would be impossible to find anything, and in Vintage Story, you can't just dig to a specific depth and find what you were looking for. So there has to be some other method of finding ores. In real life, modern prospecting has a lot of tools at our disposal. We have a rough understanding of the regional geology of everywhere on Earth, and we know most of the basic processes and history that it takes to create ores. For large bodies, we can use radar, hyperspectral imaging, aerial gravity surveys, and on the smaller scale, we take samples, go to a lab, and do elemental analysis to look at abundances. If things look promising, we can do exploratory drilling, analyze those cores, and literally map the ore body in 3D underground. and that's just brushing the surface. The specific prospecting methods you use are very dependent on the specific ore you're looking for. The Vintage Story prospecting pick tries to do a little bit of all of this. It has two modes, density and node search. In density search, you are looking at regional trends. In-game, the player breaks 3 blocks that are at least 3 blocks from each other, but all within 16 blocks total. The info log will then return information about the possible ores at that location in parts per 1,000, which makes it seem like if it shows up, it's there, just in low abundance. And that's incorrect. The game produces noise maps for nearly every ore. These maps represent the chance of an ore blob spawning in a specific spot, so higher chance areas can have more blobs in them. Those readings from the pick are reporting the value from the map exactly at the location you are prospecting in. If you do this density search in enough places, you will create a heat map. And you can select the specific ore you are interested in. We can export the noise map for this area with a command, and most of them will match up with what we see here. But some don't. It seems like the prospecting results aren't just the noise map, but maybe also combined with the available rocks that the ore needs. Like here, the exported map shows a high chance of lapis, but there is no marble for it to generate in, and the prospecting results show no signs of lapis. There are other instances when you can get a 0 result, like there is no halite here, but there is literally a salt dome exposed right next to me. So where the density search is just telling you the chance that something spawns, the node search tells you exactly what's around you in a 6-block radius. So if you're looking for a specific ore, you go to where the density was highest, you dig down, and then every 12 blocks, test it with the prospecting pick, and if you find what you are looking for, try in a few directions to see where it's the highest concentration, and then head in that direction until you find it. I actually like both of these processes, but I think the terms can be confusing. Reading the in-game guide is helpful for this, as it is for most things in the game. You shouldn't need a wiki to play a game, and Vintage Story does a good job of documenting things. On a personal note, I am all for rarity in a game, and I think it's great to have things that are difficult to find, but it can be very frustrating when you are setting out to find something specific, and even if you know exactly how the system works, you are still unable to find it. I feel like there needs to be some middle process that is like density search but for a smaller area, like the current chunk or something, and it returns the actual presence or lack thereof of ores. Maybe just call the nodes fine, medium, and coarse. There are a few more things to cover about ores in general. In Vintage Story, different ores require different tiers of picks to acquire, but you can break every rock with a copper pick. Different minerals do have different hardnesses, but in the game, the ores are pieces in a rock. The hardness of that rock would mostly dictate how hard the ore would be to mine out of it. Here is a plot of every ore split into the tier of tool needed to acquire it. If we actually plotted the mineral hardness vertically, there is no correlation between the two. This is just there for gameplay progression. The same thing goes for the pulverizer. Ilmenite is softer than quartz, but requires a higher tier. Something else with material properties. All of these ores have melting temperatures, and these are correct to real life. But we can heat several of these metals to above their melting point in a forge and they stay ingots. For zinc, you can even get it above the boiling point and it's fine. The game files have the melting and boiling points, density, and it also has specific heat capacity for all the metals, but it seems to have no effect on how fast the metals heat and cool in the game. There is also the color of the metals when they are heated. In real life, this glow is precise for specific temperatures. This glow is called blackbody radiation, and every element glows the same color at the same temperature. The colors in Vintage Story are pretty close, just something I wanted to look at. Let's shift and talk about gravity. Non-consolidated blocks that are affected by gravity don't just fall straight down and remain stacked. They behave more like real sediment. So if you remove the supporting block, they'll fall down and to the sides in a semi-random order. Solid blocks are also semi-affected by gravity. There is no silk touch in the game, but if you remove the block on every side, it will pop off as a full block. There is a gameplay mechanic that is off by default in the normal survival settings, but if you turn on cave-ins, then unsupported blocks have a chance of falling when they are updated, so it can cause large cave-ins while exploring and mining. This requires you to build or leave support columns. I was impressed that there are different strengths for different rocks, and I'm not going to get into the real-life strength of rocks much, but different rocks are very different, and it depends on the type of strength you are talking about. For cave-ins, the tensile strength plays a big factor. In-game, the igneous rocks and marbles are the most stable, then phyllite, shale, and bauxite, and lastly are the sedimentary rocks. In real life, in general, sedimentary rocks and low-grade metamorphic rocks would have low strength, especially if they have any foliation that aligns with the applied stress. Limestone is a little stronger, and then marbles, and then fine-grained igneous rocks, then coarse-grained igneous rocks, and probably the strongest would be chert. I would shift these values a bit, but it is nice that the cracked versions have lower stability. Since the game has lava and water, let's look at fluid interactions. If you run lava over water, it converts the flowing water into basalt, and then the source block into obsidian, and then that converts to basalt too? I'm not really sure what's going on here, and sometimes I've had different results. Besides that, if we are talking about realism, these should both be obsidian, or at least a volcanic glass. Obsidian is a volcanic glass with the elemental abundance of granite. Basalt and obsidian are very different. If the water flows onto lava, then nothing happens? The survival player can't move lava, but can move water, so it's strange that this is the one that has no interaction. It's also very strange that if you mine the stones made from lava on water, the water is still there. And just graphically, there's an issue with the sides getting cold even if it's seen through transparent blocks. There is one thing that I should have talked about in the last video. Bauxite is needed to make refractory bricks, and when world gen is random, it can be extremely hard to find any. The formation of bauxite in real life is done through lateritic weathering, which occurs in hot, humid areas. This process can convert rocks like granite into bauxite, so I would add some bauxite deposits to those regions of the game, similar to deposits of clay. This way, at least you would know to look in warm, wet areas instead of just anywhere. Also, it's very strange that there is a map shortcut for copper. If you select the pick and then the orange color, it autofills copper, and nothing else does that. Please add that for other ores. In addition to the geology aspect of the game, there is another part of Vintage Story that I haven't talked about yet: the gameplay. The story quest and combat are the two things that I am the most critical of. The first major story event requires you to be in the Bronze Age at least, and I did it after I had Steel. The difficulty doesn't scale with multiplayer, so doing things solo can seem unbalanced in my opinion. The story structures themselves prevent the player from changing the environment, like destroying or placing blocks. This forces the player to follow the set progression of the area, which I don't mind in itself. I actually really enjoyed the event and story. I think it would be nice if there were some smaller quests maybe given by the traders before this that you could do early on, because it seems like such a departure from the rest of the game that you've played up to this point. This could be the result of what priorities were early on in the game's development, but I think it could be improved a lot. I'm also not a fan of the late game combat. I'm no stranger to challenging games. I've been playing From Software titles since the original Demon's Souls, and I love them. I don't expect Vintage Story combat to be dodge rolling everywhere, but it seems like the intent is just to make heavier and heavier armor, which also slows down your movement and healing and increases hunger. I just don't find it very engaging. Many of my complaints would be lessened in multiplayer, which is where the game is probably strongest at. There are different classes, and they all have their strengths and weaknesses, but no geologist. Lastly, there are just a few little things that I really like about the game. You can open a chest, and then another chest. Open a lot of them. You can move items between all of them without continually moving items in and out of your own inventory. There are beams for many materials, which is so good for detailing builds. They can even go diagonally. Also, I hear people complain about how desaturated the game looks, and I just want you to know that you can change that. There is a sepia slider in the settings, and I play with it turned down. You can also change the map so it's more color accurate. And now, with all of that out of the way, we can talk about the actual review. Going into this review, I didn't really know what to expect. I had zero experience with the game or its initial inspiration, the Minecraft mod Terra Firmacraft. I don't think that a game should be a one-to-one recreation of geology and life. It should be inspired from reality, take parts, make them fun, and give the player ways to engage with the world in interesting ways. And I think that Vintage Story achieves that. I have given all my critiques in these videos, and my biggest nitpicks don't really change much for the overall experience. Ores in games are very hard because you have to have some control over progression. That's the point of a game like this. You can't have people that know the game start a world, grab some bog iron, clay, and have iron tools in no time. I imagine the hardest part must be controlling the player's access to tiers of technology and not making it just a tedious nightmare. I think that Vintage Story does an incredible job representing geology and the mechanics surrounding it. Of course there is room for improvement, there will always be. And the team is regularly adding new items and mechanics. Like I mentioned earlier, 1.22 pre-release came out, and it adds travertine as a new material, as well as a bunch of new mechanics. Looking through that update and seeing all the things that they are adding honestly made me excited, like I felt for old version updates of Minecraft, which we can talk about a bit. Vintage Story is often compared to Minecraft or mistaken for it, but they are trying to do two different things. Hytale came out, and it's doing something else too. They are similar games, but it's odd that there aren't more successful games in this genre. When I was a kid, FPS wasn't a thing. For years, everything was just a Doom clone. And I think that calling Vintage Story a Minecraft clone is unfair. So, is the game worth it? My personal opinion is absolutely. It can be overwhelming at first, but it becomes very chill after getting on your feet. If you enjoy the actual survival aspects of a game, slow progression, and rewards after time and effort, it might be your jam. That concludes my Geologic review of Vintage Story. Thank you to Tyron, the lead dev, for chatting with me and answering my questions. Making games is hard, and everyone at Onago Studios should be proud of this product. On my side, this was a huge project for me, and it took a lot of time. If I got anything wrong, let me know, and I'll add it to a pinned comment. This is the longest video I have made so far, and I actually cut out a decent number of things. If listening to me talk for this long was not enough for you, there will be a more casual video on the second channel talking about some of the things that I cut out. And patrons, thank you. I'll have a lot more to say in my commentary video for you as well. I hope you all have a nice day, and I will see you next time. Goodbye. Currently, oh my god, what's I don't know what happened here. I kind of like it.